loud. Sorry, I'm really bad at that. Thanks. All right. Now recording. We only missed 5 minutes. We're going to do method bias. Method bias is the thing that biases your measures. The thing you can't control. We just discussed it. If you missed it, go watch another video. Okay. That's for the video's sake. You guys, I'm not chatting with you that. Okay, here we go. Let's go. So, to extract method bias. Method bias is theorized to affect all measures equally. So what is it they all share in common? What is their shared variance across all measures? The way we can assess this is by throwing in a latent factor that is related to all of them. But before we do that, we also have theorized in this model that there is a specific method bias. We're asking about how well they use Excel. These guys are in an Introduction to Information Systems course. How do you think they think we want them to answer these questions? Positively. Oh, I'm great at Excel. Oh, I love Excel. Oh, I'm happy when I use Excel. I'm very curious when I use Excel, right? There's a desirable way to answer these questions based on the context of the population we're sampling. So we decided when we were collecting this data, we would also collect data on social desirability. And we've seen those questions before. They are these over here. If I scroll up right here, we asked them questions like this. I'm always willing to admit when I make a mistake. I like to gossip. These are clearly they're socially desirable ways to answer these questions. We know we're not supposed to gossip. We know we're not supposed to deliberately hurt someone. We know that we're supposed to forgive rather than forget. And forget? Yeah, forgive and forget. I can never remember. Okay, so there are very socially desirable ways to answer these. We did already reverse code the reverse coded ones. And so the theory is, if we take these 5 items, and we make a latent factor out of them, and then we connect these 5 items with all of these items, anything they share is only going to be that social desirability bias. Because theoretically, my response to usefulness, for example, should have nothing to do with whether I like to gossip, right? Theoretically, they're unrelated. So anything that they do share in variance should just be the bias. That's, again, the theory. So we're going to try to extract that little bit of shared variance. It's 2 things. We want a variable that's unrelated to everything, which is social desirability, and we want a variable that is connected to all of them, that extracts, oh, I'll just show you, it'd be easier to show you. So let's create social desirability bias. It has 5 items. So click on the candelabra, bring it out here, draw a little latent factor for social desirability, and then you're going to click on it 5 times. 1, 2, 3, 4, 5. There we go. I'm going to use this rotator thingy and click, click, click to rotate. It's this rotator thingy under the fire truck. Why there's a fire truck, I also don't know. But we're going to use the fire truck right now, actually. If you use the fire truck and the balloons, sorry, Amos is just ridiculous. Use the fire truck and the balloons. You can move this latent factor anywhere you want, and you can move its items any way you want, like that. With the fire truck and the balloons, obviously, right? So intuitive. And then what we're going to do is we're going to open up this white stacky thing. I'm sure they have real names. I just don't know what they are. And I've been using it for like 8 years. So I don't know. You can manage. He's breaking up quite a bit. Is it only me? Is the audio coming through okay for all the other remote folks? We're good. Okay, sorry for you whom it is breaking up, for whom it is breaking up. Maybe, are you not muted on your side? Because that could be giving you interference. No, if you're muted. I'm not sure why, sorry. Okay, so what we're gonna do, we're gonna drag social desirability 1 up into here. Oh, poop. Okay. Sorry. Notice it brought in the label, not the actual variable name. So what you got to do, go to View, Interface Properties, okay, View, Interface Properties, and then over here in the MISC tab, Miscellaneous, uncheck Display Variable Labels. I don't know why that's the default. And there's no OK button, just hit close. And there we go, you see it's now social desirability 1. Okay, let's pull over the rest. Social desirability 5, and 6, 8, and 9. Now I'm actually going to move these error terms over here. There we go. Again, I use the fire truck and the balloons for that. And then I'm going to name this, double click it. I'm going to name it in the text area, variable name, social desirability, social des. Can't have any spaces, by the way, in your variable names. In Amos, it doesn't like that. And then I'm going to use the plugins, name unobserved variables. That's going to name all the error terms systematically. I'm also going to highlight all of these latent factors. With the pointer finger. And then go to plugins, draw covariances. And that's going to connect them all automatically. Draw. Does this assume we've gone through the invariance process? Yes, but I'm using the initial CFA model after having deleted the anxiety items and the playful item that we dropped during the invariance test. In Amos 23, it will default to the left. In Amos 24, it will default to the right. Why? I don't know. But you can draw them manually, and they only draw clockwise. So you can't go from bottom to top if you want them on the right. You gotta go from top to bottom. And to draw them manually, it's the double-headed arrow. Yeah. No, I went to the CFA that only has one group, one model, but in it, I applied what we learned during the invariance test. So I got rid of anxiety 2, 4, and 6, and also playful 6. A new CFA, yeah. But again, with only one group. While we're waiting on things, I'm going to move this guy. Oh, the numbers would be a little different. Yeah. Yeah, the numbers would be different. Okay. Okay. Here we go. So now we have social desirability in there. I'm also going to go to plugins and do resize observed. Where's that? Resize observed variables. Now they're all the right size. There we go. Okay. I'm going to save this as CFA CMB. CFA CMB. CMB stands for common method bias. Yes, replace. There we go. And so now if you're following along and yours just keeps breaking, you can just use this file. I just saved it to Google Drive. Okay, theoretically, social desirability should have a low covariance value with all of the other latent factors. So if I run this, hit the up arrow, look at the correlations here from social desirability. Let me zoom in. 0.04, negative 0.06, 0.15, negative 0.07, 0.04, 0.06, very low covariances, correlations, excuse me, which is what we expect. It should not be related to these other variables. It's theoretically unrelated, which is good. That's what we want. So this is called a marker variable. Marker variable. So we now have a theoretically unrelated marker variable. And now what we're going to do is throw in a common, unmeasured common latent factor. To do that, hit the down arrow here. Go click on the ellipse and just create a big old latent factor there. If you have the plugin from earlier today, this common latent factor connector, don't click it yet. You want to highlight with the pointer finger your big fat variable. So it's blue. And then go to plugins, common latent factor connector. What that does is it connects it to all of the observed variables. So you don't have to do it manually. There we go. And it names it, CLF. It only works though if you've highlighted that big latent factor. There we go. Deselect. So what we want to do, what we're going to do now is if we run this, what should happen, just hit proceed. What should happen is it should say, because this common latent factor is connected to all observed variables, and the way that works in AMOS is it finds the shared variance among all of the items. The only thing they should share, since social desirability is not related to them, the only thing they should share is that bias, that social desirability bias. Everything else should be stay put. So what we want to do is compare this unconstrained model, where we pull out the method bias, to a fully constrained model where we say there is no bias. We're going to say we're going to do a chi-square difference test where there is no bias and where we're letting the bias range roll freely. If they're no different, then there's no meaningful method bias. So check the chat real quick. Too fast. Yep. Sorry. Okay. I'm terrible about going too fast. Where do I need to go back? I'm just going to delete this. Okay. Social desirability is in there. Remote folks, if you want to unmute and you can talk, I'll go slow for you. Or not. Hopefully it's covariated with everything. The next step, grab the ellipse, make a big one, click and drag, and then use the pointer finger to select it. Click on it. So now it's blue. Well, when your mouse is over it, it's red. When you leave it, it's blue. If it's not blue, this won't work. Go to plugins and common latent factor connector. If you don't have that, that means you didn't install it this morning together with us. And if that's the case, go to the video on YouTube called CLF plugin. There we go. Are we up to speed, remote folks?
It just doesn't connect for me. How do you?
Make sure it's highlighted. So you have to use the pointer finger to turn it blue. And then don't name it CLF. It'll name it for you.
Okay, just did. Yeah.
Woohoo! Yay. Can you explain again behind the idea of CLF, shared variance? Yeah. So the idea behind the CLF, it's an unmeasured latent factor. We didn't use any variables in our survey to measure this thingy, this CLF. What it is it's extracting variance from all of the variables in our model. And the only thing it will extract is what it shares in common across what all the items share in common. Now, they shouldn't share a lot in common because if you look at the correlations from social desirability, it's not related to all these other constructs. So the only thing they should share is the only thing that should be pulled out is what is shared with social desirability, which is the bias, the method bias we're trying to get rid of. That's what the CLF is for extracting the method bias produced by social desirability. So so Varun's point, you can actually do this without social desirability if you could find some unrelated latent factor. And you can do this by trial and error. Throw a bunch of latent factors in there from your same data set and find out which one has the lowest correlations with all other latent factors. Oh, yes, you could, but. Right. There's a CLF that's pulling that shared. Yeah, the CLF's the thing that's pulling it out. The problem with not having a marker variable. Let's say, well, theoretically, we believe that all of these variables in our model are related. In fact, we did an EFA and it showed us these are truly related constructs. So what did they share? It's more than just social desirability bias or some method bias. They share some trait variance. And so if you don't throw in an unrelated marker variable, the CLF will pull out that shared trait variance. It will actually break your model. Some of you have probably done method bias before and you threw in a CLF and it broke your model. That's why. It's because it's pulling out trait variance instead of just method variance. Because because the trait variance isn't shared with the social desirability items, it will not be extracted. The only thing being extracted is what is shared across all items. Yeah, that's why you have the unmeasured one in there. Which is also why you can throw in any unrelated latent factor and it could work. Although there are studies by McKenzie, Podzikoff, McKinnon, who show that that could do more harm than good if it's not theoretically justified. Like social desirability is theoretically justified. The case I talked about before, asking me about my institution, loyalty in that case would be a theoretically justified marker variable. In this case, well, loyalty would be the reason for the inflation. In that other case, in this particular case with social desirability, we're saying social desirability is the reason for the inflation in response.
You wouldn't want to use this every time. There's going to be studies for social desirability.
There are studies where social desirability is a construct of interest. But when I did that study of bribery in Nigeria, social desirability had to be a part of that study because there's clearly a right way to answer those questions, right? Yeah, I don't steal, I don't lie, I don't cheat. That's the only way to answer those questions. Okay, chat box, let's see. Can we add CLF without adding marker variables? So we just addressed that. Yes, you can, but it could break your model. What about the other reason for common method bias, such as using the same participants from a particular set of population? I must misunderstand. The reason you might have method bias, so they list several reasons for method bias existing in the literature. One is you have questions that there's a clear, correct, quote unquote, correct way to answer those questions. Another is if you have the dependent variable being measured in the same survey as your independent variables. Whatever is affecting you when you're answering independent variable questions will affect you during the dependent variable question. So it's the same, it's the same resource, the same instrument you're using for both measurements. Sorry, I talk so fast. Okay, we're good? Okay, got it. Okay, I will try to slow down, but I'm really bad at it. Can the marker be related to a group? Ooh. So we're testing, right now we're testing gender differences. Could there be a different marker for different groups, like for male versus female? Yeah, theoretically it makes sense. I've never seen a study on that. That'd be fascinating. You should publish a study on that. Whoever said that, WD Marcus. That'd be fascinating. You could publish that well. Okay, but then you're just adding more work for us. So thanks a lot. Okay, here we go. So what we want to do, we want to compare this unconstrained model where method bias is allowed to be extracted to a fully constrained model where we're saying there is no method bias. And if those models are equivalent, that means there is no method bias of meaning, of substance. So let's do that. Let's run this. Just hit proceed. It's going to throw you an error initially. It just means your CLF isn't correlated with everything else. So hit proceed. We just want to grab the degrees of freedom. And actually, before we do that, we want to see if it broke our model. So let's see if it broke our model. We can just hit the up arrow and see if there are any weird. Oh, there is a weird one. Look at useful. Negative loadings. Everything else looks, oh, no, decision quality, broken. Information acquisition is fine. So decision quality and useful, broke. Darn. That's unfortunate. So, things we can do. That tells me that the CLF right now is messing with the algorithm. It's messing with the estimation. And so I would say, practically speaking, I would not draw conclusions yet. Yeah, because really it's just breaking the Amos estimation. It's not saying, oh, you have method bias. I wouldn't yet because I can tell it's broken. I would try to fix it first. And how do you fix a broken model in Amos? It's really stupid. You try to figure out where the problem is and then fiddle around with how it's specified. Yeah, it's usefulness and decision quality. They got inverted is what happened. Yeah, so what happened when you have an inversion of the loadings, what that means is that they are, the part of them that was positively related to everything else has now been sucked out, and the only thing left is the part that's inversely related to everything. So let's see if we can fix it. Let's go to the output. And I'm just fiddling around here. I didn't anticipate this at all. So you can see over here in decision quality, I'm looking in the regression weights in the estimates area. I'll zoom in. So click on estimates, and you'll see the first table, regression weights. If you look at the standard error column right here, you'll see some of them are getting some slightly larger standard error. If you go down to this one, decision quality, boom, massive standard errors. That means it's broken. So what I want to do is fiddle around a bit. Is there any logic, rhyme, or reason to the fiddling? Not that I've figured out so far. If one of you figures it out, let me know. So here's where we're going to go fiddle. Check this out. We have on useful, we put the variance out here. Right, the variance is out here. Let's move it back onto a line. So double click a line, change the regression weight to 1. Sorry, so let me pull it over here. So we had the variance constraint to 1 here. I'm going to delete that. And then I'm going to add that constraint to a regression weight of one of the lines. I just picked the top line for now. And you may say, well, what on earth could that possibly do? You'd be surprised. We're going to try running that again. We're moving the anchor around is what we're doing, to see if we can stop it from derailing the estimation. Correct. Yeah, really it's an unstable model. We're trying to stabilize the model by leading it down different paths by constraining different regression weights. That was the only one that was different. Yeah, all the rest were actually in here. So let's see if it worked. If I hit the up arrow, hey, they're all positive again. Magic. But look at decision quality. Garbage. So we need to go figure out something there. Let's go look at the output. Look at that. Yeah, 92, 89. Ideally, yes. Let's go. It's still broken though. So let's go fix it. Let's go to our output. Go look at estimates. Look at decision quality and see which one is the worst. Here's decision quality. Look, decision quality 10, huge standard error. Let's just try moving that constraint to decision quality 10. See what happens. I don't know if it'll work. So I'm going to down arrow this so it's editable. Get rid of the constraint on decision quality 7. Delete it. And then go to decision quality 10 and make it a 1. And then zoom out, run it, please work. Oh, 14 iterations? That should work then. Hey, look at that. It worked. We got lucky. Information acquisition has a couple problems. I'm going to zoom in there. So look at decision quality is fixed, mostly. Information acquisition, we have a 0.11 loading, a 0.29 loading. Not that great, right? So let's just check out that output. Estimates, information acquisition, looking at the error here. Really, it's number 4. Even though that's the lowest one, look at the p-value, look at the critical value. That's the one we're really concerned about. The ratio between the critical value and the, too deep. Never mind. Look at the p-value. It's the one that's not even approaching significance. Let's just put the constraint there and see if it helps. It might not help at all. At the standard error. No. What's the difference? It's the size. I didn't get into it. I was about to get into it. It's the ratio of the critical ratio, the CR, and the standard error, which actually is just the p-value. That's what the ratio of it is. That's what a p-value is. So with the other ones, they were just so big, it was easy to see the differences. With information acquisition, they were smaller, and so it's harder to see the differences. So I just looked at the p-value directly. Okay. Move that to 1. Oh, no, not that one. Delete. I'm going to move it to 4 here. Please work. Please work. So is there a rhyme or reason to what I'm doing? Again, what we're doing is we're moving around the anchoring points for the algorithm, for the executing, calculating the estimates. And as we move around those anchoring points, it changes the trajectory of the algorithm so that it doesn't go off the rails. And you think, wow, that sounds really unstable. Like it's built on such fickle algorithms that it could go off the rails if you just move the constraint around. The answer is yep. Notice this one didn't work. Can't. Didn't even run. This one's so unstable, it reached the iteration limit. That is hard to say. Reached iteration limit. So since it reached the iteration limit, and how do I know that? Because it says right here, iteration limit reached. Typically, increasing it is it's a way to see if it'll run at all. But you want it to iterate. You want it to minimize within a dozen or 2 iterations. Okay. So let's go back over here and let's just move it. So it's not on 4 anymore. I'm just going to move it to 3. There's only one other choice. So after that, not going to take long. Proceed. Hey, 16 iterations. I like that. See if it worked. And it worked. Oh, I'm always surprised when it works. Look at that. That's back up. Decision quality is broken again. Everything else looks fine. So you know what's going on here. Decision quality and information acquisition share a lot of variance. And we're pulling that out. Notice the correlation now between these two is low. We're pulling out a piece of that. And we're changing which piece we're pulling out as we move this constraint around. So we're going to go and try to fix this again. Oh, you start questioning the model and your sanity after you've tried every permutation of this. What I would do at this point is so if we can't fix this, let's hope we can't fix this, so I have to go into this. But what I would do if we couldn't fix this, I would take decision quality as it stands right now and information acquisition as it stands right now, go back to the EFA and throw them into their own EFA and try to pull them apart as far as I can. Yeah. Yeah, we predicted this might happen because they're so related. Yeah. We looked into the future. Okay, gonna down arrow this, try to fix it. So was it decision quality? Yep, useful still working. Now it's decision quality. So we haven't tried anything with decision quality yet. Let's move around this constraint. Take it off of 10, move it to the top one, 7. Or we could go look at the output and change it based on that, but I'm just going to do it sort of trial and error here. Run it. You guys, if one of you figures it out before me, tell me which one to put it on. That one hit 44 iterations. Guaranteed that wasn't the one. Nope, that made it negative. Okay, let's try again. Run 8. What would you write in your paper about all this? Would you say, yeah, we had a really hard time figuring this out. We messed with things so hard. That's right. You would not say anything about this particular procedure. I mean, you could, but it just throws up an unnecessary red flag. I should also mention while we're trial and erroring here, trialing and erroring, is that, anyway. That one didn't work. The last one is number 12 here. We already had 10 going. When you add the CLF, you're adding a lot of parameters. So if you have a low sample size, the CLF might just break your model anyway, because you just don't have enough sample size to address it. Still broken. Okay, there is actually one other option we could do. We could put the constraint on decision quality variance and take it off of a path. This is the last thing. If this doesn't work, there's actually something else we can do. Sorry. Yeah, there's more we can do. Yep. Oh, okay, here's the last thing we can do. Since it is so tightly connected with information acquisition, we can start changing information acquisition. So we changed it already once, right, or twice. Let's try that final option, which was number 2, information acquisition 2. Put a 1 there, delete the 1 here. This is almost our last option here. Although we could permute and do every possible combination, but I'm not going to do that. It ran, that's good. So information acquisition still works. Decision quality does not. So here we are at this point. We need to go back to the EFA. But not from scratch. And we don't have to redo all of our analyses. It's just this piece, yes. That's what I'm saying. Decision quality is broken. I could pull one out and see what that does. The problem is I don't know which one to pull out. The one I want to pull out, No, the one that I want to pull out is the one that is most strongly related to information acquisition. Go back to EFA. Yep. So let's do this. Okay, if you don't want to follow at this point, just watch. That's cool, and then I'll report back. So let's watch. Let me address chat real quick. What exactly is the regression weight? Oof. It's the slope of the relationship between x and y. In this case, the x is, let's take useful right now. The x is useful, although it doesn't have an exact value. It's the aggregate value of all of the correlations of all of its items. So in practical words, the regression weight in this context is the extent to which that item relates to all other items within that factor. That's what a regression weight is. So can the constraint be shared between two items? You wouldn't want to put multiple constraints in there, although you could and it should still run. But I don't know any reason to do that. If you have to throw them back in the EFA, does that mean that you have to now have a new model and you have to start everything over again? Yes, no, you don't. We're gonna keep all the analyses we've done so far as stable, and we're gonna say we had to make some changes for the CLF. All right, so back to SPSS. Factor analysis. Get rid of all of this. Except information acquisition, 1 through 4. Decision quality. Let's see what they were on decision quality. It's 7, 8, 9, 10, 12. 7, 8, 9, 10, and 12. And looks like we still have things going for us here. It pulled out 2, which is what we expected. Here's the pattern matrix. It looks perfect. So what we need to do is we need to not suppress. Options, don't suppress small coefficients. Also, I'm going to sort by size. Okay, check it out. Here's the pattern matrix. We see the weakest decision quality is 12, and it loads at a 0.208 on information acquisition. The weakest information acquisition is 4, and it loads at the 0.201 on decision quality. That's really convenient. The lowest loading on both is also the highest cross-loading on both. So I'm going to start by getting rid of 12. Why? Because it's a higher cross-loading and the lower loading, and it has 5 items instead of 4. So getting rid of decision quality 12. Run it again. Here we are again. Looking pretty solid. No major cross-loadings here. Sorry, I should zoom in for everybody to see properly. And then over here, loading really well, except information acquisition 4 has fairly strong cross-loading. I will bear that in mind. I'm not going to delete it yet because we have 4 items on that latent factor. Let's keep it that way. So we're going to go back to the CFA. That was a nice quick detour. We're going to delete, down arrow. We're going to delete decision quality 12. And its error term. We're going to pull the variance constraint back onto a regression weight. Let's just pick 7. So now our model looks like this. And let's see if this runs. Sorry, was that too fast? Nope, didn't run. Excellent. Was there anything in our initial EFA that would have signaled this problem between decision quality and information acquisition? Yes. We had a large correlation between information acquisition and decision quality in the EFA. And we noted that and said, oh, look, these are highly related. We'll probably have discriminant validity issues between them later. Okay. With this in mind, let's move this constraint around one more time. Discriminant validity. Yeah. Okay, moving this around just a couple more times. Run this. Proceed. Oh, did I move the one on comp use? Whoops. I'm moving the wrong one. going to move it to 8. It's running. Oh, maxed out. Doesn't like that. Move it down one more to 9. Nope. Move it to 10. See if it runs. Oh, won't run. So let's change information acquisition. The most stable constraint we had last time was on 3, I believe. So let's stick it back on 3. It ran. And it almost worked. Oh, it's better. It is better. Look, I actually have a strong loading here on 10. I'm going to move it back to 7. Hopefully this will be the last move. You may think to yourself, wow, this is amazingly tedious. Is this what professors do? Yes. This is what research assistants do? No, they're not clever enough to figure it out. That didn't work. Moving it again. And then you may think, well, couldn't you automate this? It sure is tedious. The answer is I'm working on it. Or, well, one of my research assistants is working on it. Yep. Yep. Because I just moved information acquisition's anchor to a stable location. It's on 3. What we might have to do is just delete information acquisition 4. I just hate to do that. But looks like we need to. So we're going to do it. Adios, number 4. We only had 4 items. I hate to drop it below 4. 3 is fine. It's just 4 is such a nice number, except in Chinese, where it means death. That was for you. Jacob, not you. I don't know who you are. Jacob speaks Mandarin. Here we go. We're going to run this. Please work. Nope, didn't work. All right. Oh, wait. No, it did work. Did it work? Look at the output. No, it didn't work. Okay. All right, we're getting to a point where I'm getting exhausted too. Try a few more. Hopefully you never have this much trouble. Only when you're demonstrating in front of live participants. I'm doing this intentionally because this is real. This is so real. Okay, I'm really glad it didn't work. And I really am. And here's why. Yeah, believe me, I'm really glad it didn't work. Here's why, because more often than not, it's not going to work. Because every paper ever written on method bias essentially says there's no good way to measure a method bias. And often you're doing more damage than good. It's good that you're aware of it, but there are very few things you can do if it breaks your model. So what we would do at this point is we would say, well, it's not running. We simply cannot get our model to run. Therefore, we accept that there is some method bias, but we can't run it with the common latent factor in place. We're going to delete the common latent factor, run the model, observe that it does actually run, and that the values are wonderful, and move on. Notice I retain the social desirability construct because we're going to control for that because we know it exists because it broke our model. So we're going to now control for it moving forward. But that's all we can say. All that little fiddling, I would never report that. Yeah. Yeah, so this doesn't, no, we don't have to go back. This does not match our EFA anymore, right? It doesn't match all our convex alphas. But it can only be tighter at this point. So we don't have to go back and redo the EFA, no, because we're going to do a composite reliability next. Yeah. Okay. Yes. Let's say it didn't break.
The top journals, they're not going to be happy. Is it enough to say, let's say that we have a different way of collecting data for our deep and variables?
Oh, you don't even have to test method bias if you collected them on separate instruments. Not an issue.
Even though all my independent variables are separate.
If they're separate, it doesn't matter. Yeah, if your dependent variable was collected on a different instrument, or if your dependent variable was objective and not a subjective perceptual measure, yeah, you don't need to do method bias test at all. And there are papers that state that. The Podscott papers say that right outright.
Would this imply then, if you're going to control for it, that you're going to use this scale in future iterations, you should be able to social desirability scale with this so you can control in the future context?
So for the remote folks who couldn't hear that, since we know that there's a method bias issue going on here, and we think it's social desirability, should we then, going forward, make sure that people always use social desirability bias with our measures? And the answer is it's their responsibility to read the paper and know that social desirability was an issue. And so they should adopt that. Yeah. Okay, real quick. If it didn't break your model, I just want you to watch. Don't follow along in this case. Just watch. Let's say it didn't break your model and you were moving forward with the common latent factor. So I'm going to throw it back in again. Don't follow along. Just watch for a sec. I'm going to put it back in. I'm going to select it just to get it all back and set up. Wait for it. There it is. What you would do is you would do a chi-square difference test between this and a constrained model where we constrain the method bias to be 0. So I'm going to run this, see if I can get it to run super fast. And the way I'm going to do it is by increasing the iteration limit, which is a terrible, terrible thing to do, but I'm going to do it anyway. Because what you're saying is, my model is too unstable to converge in a reasonable number of iterations. So let's increase the number we allow because of the instability. But we don't want an unstable model. That's saying it's cool to be unstable. It's okay. But it's really not. Yeah, letting a student repeat a class multiple times, we can do it, but it's not a good thing. So let me run this. See if it runs at 500. It's gonna run, not even at 500. Let me, all right, I saved this elsewhere, right? So I'm just gonna destroy the model real quick for purposes of this demonstration. I'm gonna get rid of information acquisition just for this demonstration. Don't do this in your model right now. I just need a model that runs so I can show you what you'd actually do. And it still runs up to 500. Holy cow. Get rid of decision quality. Okay, I just need something that runs. It doesn't matter what it is. In your model, obviously, you wouldn't do this. I'm just trying to teach you what you would do if you didn't have a broken model. Yeah. What is going on? What? I'm confused. I'm going to say it's anxiety. Giving me anxiety. Let's see. I know. I just need something that'll run. That's all I need. Yeah, because that one ran, right? Yeah. There we go. This one runs. We know that. Okay. Actually, going to move this really quick. down to where it was. Here. Okay, this should run. Hopefully. It ran in 47, which means it did run. Okay, so what we would do is we'd run a chi-square difference test between this and the zero constrained model. The chi-square here is 629. Pull that over into the stats package. This is the unconstrained model. Degrees of freedom is 441. And then we constrain the model to be 0, saying that there is no method bias. And we'll see if those models are equivalent. Name this CLF. And plugins connect. What it's going to do this time is it's going to create zeros, 0 constraints, constraints of 0 on all of the paths. So the way I did it differently is I named it. If you don't name it, it doesn't constrain anything. If you name it, it'll constrain everything, which is not intuitive at all. I realize, sorry. I should have made that more intuitive. If you name it CLF, it'll add zeros to all the paths. If you don't name it CLF, it'll just add the paths unconstrained. It's in the video. Yeah. Sorry, I should have made that better. I didn't. It is still better than doing it by hand. That is true. Okay, this ran. Chi-square is 761. We'll go over to the chi-square difference test. And the degrees of freedom is 474. Oops. 474. Ooh, so what does this tell us? This tells us we do have method bias. What it's saying is the pretended 0 method bias is not realistic. It's not equivalent to an unconstrained model. So there's something other than 0 method bias, which means we need to keep social desirability in, which we knew already. And so we're control for social desirability moving forward. Okay, back to chat. To say there is method bias? Yeah, definitely. As long as you control for it moving forward. Yeah, so as we move on to a causal analysis, we're going to leave social desirability in there, and we're going to then regress so social desirability on the DVs and any endogenous variable, and we're going to covary it with all exogenous variables. Yep. Yeah, we'll show it in Amos. If we want to show it in a conceptual, not in a conceptual model, but like in a final model in our paper, we would list it as a control. So we wouldn't be one of the main boxes. It'd just be in the box of controls. Yeah. Like over here, we would list it. Where's our model? Up here. We would list it right here with age and frequency. I would add social desirability right here. It'll be covariate to everything, but so will our controls. Yeah. In the causal model, we'll control for its effects by regressing, well, adding regression lines from it to the DVs and the mediators, and by covarying it with all the independent variables. Yeah, you'll see. Okay. Chat. Removing decision quality 12 doesn't affect invariance tests. It might, who knows? But it shouldn't. It was that item didn't pose any problems during our invariance tests, so it shouldn't cause problems now. If removing decision quality 12 and information acquisition 4 didn't help with the method bias test, why don't you put them back in? And so now I have. Can the constraint be moved around in the CLF? Okay, actually forget it, they're all the same, yes. Can we have a quick break? Yes. Yes, let's have a quick break. This is a good break point anyway. After this is convergent and discriminant validity and a final model fit test. And that's it. for CFA. CFA is a beast. Yeah. That's it. And then we'll do some one-on-one, or we can do some extra stuff if you want. So let's take a 5-minute break. Ashika, I just dropped the degrees of freedom and chi-square in there. It is hiding over here. So you can see in the Amos output on the notes for the model, here it is on the default section, notes for the model. There's chi-square, and then degrees of freedom. This is for the zero constrained model, so the fully constrained, because I have zeros here. The other one I had was for the unconstrained, where there were no zeros. Hope that clarifies. Okay. Whew. Yeah, we should talk about that for sure. Yeah. In fact, I have a great example of this. Decision quality information acquisition. Let's make those one thing. Anybody need any one-on-one? Tomorrow? All right. Yeah, here I come. Does making it feel more complicated or less complicated? Because now you know what's going on. Ignorance is bliss. Yeah, figure it out. Going a little deeper. Yeah.
Yeah, we can.
Yes, I like this. One of them is a child. There was no luxury. Anywhere. Anywhere near.
Yeah, I was totally right. Yeah, so once I took
Okay, let's get started again. We have some time. That's good. Another option for how we roll today is depends on how mentally burnt out you are. We can roll over into tomorrow's topics and then hope for all of tomorrow after lunch to be open, completely open. So we finish all our topics in the morning, and then you have all afternoon tomorrow to either fly home or work with me one-on-one or go swimming, whatever, skiing. You can actually swim and ski tomorrow in the same county. So we could do that, or we could just be done after this. We could be done and do one-on-one, and then we'll do all tomorrow's scheduled topics tomorrow. I don't know if you guys have a preference. Tomorrow afternoon, so tomorrow's topics are causal models, mediation, moderation, multi-group effects, control variables. That's it, really. Yeah. Oh, pieces of it, and then finish it up tomorrow morning. You have everything afternoon, after 12 noon tomorrow would be completely open. Or we could just stop force feeding you information this afternoon and pick up all our regular topics tomorrow. Vote against cramming? Anyone voting against cramming? So, okay, voting for cramming? Yeah, there's about half and half there, huh? Yeah. I'm recording everything. Okay. Okay. And the speed run is an even faster recording of all of it. Yeah. And then you can watch it at 2 times speed. Yeah. All right. All right. One-on-one. Yeah. I can, Isaac. I can do one-on-one with you guys remotely as well. And okay. Yep. I have everybody remotely saying no. Okay. Okay. We'll just do what we had scheduled. That's great. And who knows? Maybe we'll finish tomorrow morning early anyway. Who knows? Yeah, I can do stuff here, so if you want to watch, that's cool. If they're okay with it. There are some things, like with the DM students, we can't share. Yeah. Yeah. I can't do it on the big screen. Right. Okay. Okay. So, we learned that social desirability bias was affecting our model. We're going to retain it. I'm actually going to delete the CLF at this point. I'm going to save this. This is CFA CMB. I'm going to save this. The next thing we're going to do is we're going to look at validity and reliability. We're not too concerned about the validity and reliability of social desirability, but everything else we are interested in. So there is a plugin for this that you got this morning called Master Validity. You just click that button. Oh, the magic that happens if it works. You created this by hand? I am so sorry. I'm so glad. Can you appreciate what I've done here? So once upon a time, you had to calculate all of these things manually. And everyone had to do it. So why don't we just automate it? So CR stands for composite reliability. This is like a Cronbach's alpha, but updated. It takes into account error a little bit better than Cronbach's alpha. We want this value in this column, this CR column, to be over 0.7. We're really good with this group. Again, social desirability, we're not so concerned. It's a control variable. We're not theorizing about it. It's just a control. Yeah, in fact, I might actually just delete this row in my correlation table. Yeah. Here we tried some other items that might have worked. Yeah. So for the remote folks who didn't hear that, we had 10 social desirability items. Probably the smart thing to have done was to try swapping in and out the other social desirability items to see if they would work better. We did CMB already. We removed the CLF off because it's breaking our model. We can't run it with it. And now we're doing validity, reliability, and model fit tests for our final model. Oh, if the CLF worked, I'd still take it off because the CLF is just a tool for pulling out the shared variance. But now that we know there is that shared variance due to social desirability, we're just going to control for it going forward. Then you do the validity. Yep. Remove the CLF and then do validity test. Yes. What we've done so far, it's kind of funny. We as scholars, we spend months designing surveys, collecting data, cleaning the data, validating the data, which is all that what we've done so far. We've cleaned and validated. That's it. And then we have this model that we've had for months and months. We haven't even tried testing our hypotheses. The actual test of our hypotheses is going to take 5 minutes. This huge buildup, and then it failed. Yeah. Or worked. You know, it could work. Yeah. To make sure that when we do this, we can have confidence that our results are valid. Yeah. It's crazy, all the buildup to actually test this. And what's scary is that people will skip all of this, including pre-testing. They'll grab their data, which they've never pre-tested or pilot tested. They'll make averages out of their items, and then they'll regress them. And that's their, I mean, that's it. You never know if what they are testing is actually valid. And they'll make conclusions on it, and they'll publish it. It gets published in these places, and then media jumps on it and says, hey, look what we found, you know, chocolate cures cancer. And it's all based on invalid measures and bad science. Anyway, you're welcome. If you want to do that, by the way, you just can't publish in a top journal anymore. You can still publish in the lower tier journals. Go for it. Just not in the top journal. Okay. Here we are. Back to this. You want so we're looking at convergent validity, which is how well do items hang together? How tightly are they related? That's CR and AVE. AVE stands for average variance extracted. We want the AVE greater than 0.5. In this case, it is. What if it weren't? By now, it really should be. We have done so much pre-work that we should not be failing at this point. But if it were, let's say information acquisition had a less than 0.5, what could we do? Well, information acquisition only has 4 items on it. We could perhaps delete the lowest loading item. We have 3 left. Or we could look at the composite reliability. There is a paper by Malhotra and Dash. I'll just show it. Malhotra and Dash, Control F dash. Control F, Malhotra. That's not the one. It's over here. I'll get it. Control F dash. There it is. This one. Here's even the quote for it. Zoom in. So I'm just going to read this straight up. AVE is a strict measure of convergent validity. Malhotra and Dash 2011 note that AVE is more conservative measure than CR. On the basis of CR alone, the researcher may conclude that the convergent validity of the construct is adequate, even though more than 50% of the variance is due to error, meaning the AVE is less than 0.5. This exists. AVE is very strict. So, if you're a liberal statistician, there it is for you. That's on my, I'm actually just going to add this really quick. We'll see to the other page. So it's there as well in the references page. Okay, this would be under measurement models, confirmatory factor analysis. Right here. There we go. Excellent. Now it's there too. Okay. Okay. So you just look at the CR. It's not a great practice, but when all else fails, there it is. Maximum shared squared variance, MSV. Nobody uses this, so don't worry about it. It's just what is it most related to? It should be less than the AVE in all cases. Max R, H. Nobody uses that either, so don't worry about it. It's just a more robust and easier, I don't say easy. It's a more robust measure of reliability. But again, nobody uses it, so nobody will know what you're talking about, so don't use it. I just put it in there for some guy contacting me. Okay. On the diagonal here, you have the square root of the AVE. According to Fornell and Larker, which I haven't listed here, oops. According to Fornell and Larker, you need to have this be less than any correlation with another construct. Yeah, greater than. Did I say less than? I'm sorry. Thank you. Greater than. The square root of the AVE should be greater than any other correlation. So in this table, if there's a problem, it will highlight it in red. So we don't have any problems. In fact, the closest problem is this one right here, information acquisition to playful. Is that really the worst? Yeah. It's the closest to 0.758, but it's still not a problem. That's the wrong reference. Yeah. The square root of the AVE needs to be greater than any other correlation to its left or to or below it. So playful right here is a 0.760. Its correlation with anxiety is 0.068 or negative 0.068. It's bigger than that. The reference is actually not Hu and Bentler. That's for model fit. I need to fix that. Sorry. It's Fornell and Larker. Those are the square root of the AVE. And then these are the correlations, all these numbers here. That reference is Fornell. Here it is, Fornell and Larker. That's for discriminant validity. Yeah. Yeah, people put it in different places. For me, I always do the square root of AV on the diagonal because that's where you put the correlation matrix and it's supposed to be compared to the correlations. It makes sense to put it there. Yeah. But you could also just put it under the numbers here and put the CR down the diagonal with Farmax alpha. Yep. You can format it however you want. If there are validity concerns, they'll be pointed out down here. We only had some for social desirability, and again, we don't care because it's just social desirability. If you had discriminant validity problems, what would you do? You go back and do that EFA, like we did with decision quality and information acquisition. Go do an EFA with just those two factors and figure out how you can separate them as much as possible, and then stick them back in and do this again. Yeah. Oh yeah, so check this out. We give a recommendation for convergent validity, try removing social desirability 1 to improve the AVE. If we go look at social desirability 1 over here, hit the up arrow. It does, a little bit. For everything else, it should work just fine. Social desirability, what it does is it says which one's the lowest loading. Yeah, it just looks at the lowest loading and says, take that one off. I'm sure. Okay. Okay. What would you report? You'd literally just copy this table into your manuscript. And you'd explain convergent validity with the AVE, reliability with the CR, discriminant validity with the square root of the AVE compared to the correlations. That's it. Throw that in there. That's one paragraph. And you have established validity and reliability. Discriminant validity with the square root of the AVE on the compared to the correlations. That used to be such a long process. Yeah. Oh, so when I first learned this, we spent an entire day, 8 hours, on that piece because of all the calculations you had to make. And as soon as you found out it was wrong, you'd have to go fix it and then redo the whole thing. And oh my goodness, that's why I automated it. Oh, I ain't got time for that. Ain't nobody got time for that. Here we go, chat, and then we'll move on to model fit. Didn't we find, yes. I spent half a day creating that table. Yes, you're welcome. Okay. Okay, the last thing to do is model fit. And we've done that before, but I also have a plugin for it. Before we didn't look at the plugin, let's look at the plugin. So plugins, model fit measures. Here we go. Zoom in. So we have this thing that provides all your model fit estimates and how good they are, and where the thresholds come from, and some recommendations. Isn't that awesome? I found myself on a bunch of consulting gigs having to recreate this table so many times. So we just wrote a plugin for it. I didn't write the plugin, I just consulted on it. My research assistant did it. So here are all the measures that I find important. The chi-square, the degrees of freedom, which don't have thresholds because they vary based on sample size and complexity. Their ratio, which does have a threshold. This is excellent. Here's the criteria right here. CFI is supposed to be greater than 0.95. We have 0.956. SRMR greater than or less than 0.08, and it's right here. RMSEA should be less than 0.06. We have a 0.04. P-close is phenomenal. Should be greater than 0.05. Again, if they're not at those thresholds, we use these other terms, acceptable and terrible, just to make you feel bad. And if they aren't at those thresholds, we provide recommendations for how to fix them. I wish I had an example, but and this is the correct. This is the correct. What's it called? Reference for this. Okay, that's it for model fit. We've spent a lot of time on model fit, so I'm not going to belabor it. But there's a plugin that makes it fast. Okay, that I think is all we were going to cover. Let me check out the slides, make sure we haven't missed anything major. We ended there. Okay, we talked about degrees of freedom. A note on degrees of freedom. Degrees of freedom are essentially the parameters you could have included but didn't. And by parameters, I mean lines, arrows. So the number of degrees of freedom is the number of arrows you didn't include. So if I delete an arrow, I get a degree of freedom. Determining fit, we talked about these measures, and these measures, and these measures. What causes poor fit? This is important. Poor fit can be caused by misspecifying. We talk about formative versus reflective. If you have a reflective model specified formatively or a formative model specified reflectively, that's mismatched and will cause fit issues. Of course, in AMOS, you can only have a reflective model anyway. So if you have a formative factor in your reflective model, that's a problem. Also, if you have a first order factor that should be combined with another one into a second order factor, but you're keeping them separate, what that's doing is it's keeping it from its natural state, which inflates the chi-square. Or if you have a second order factor that really ought to be broken up into its first order factors, that could inflate the chi-square. Overspecification, so if you add too many covariance arrows to errors or something like that, that can mess it up. Validity and reliability issues, so if you have poor measures in general, low loadings. This is a big one, neglected assumptions. If you skip all the cleaning and screening and EFA that we did, then yeah, if you get bad model fit, I'm not going to be surprised. I get that a lot. My model fit's terrible. Did you do an EFA? No, these are established scales. Well, you still need to do an EFA. Did you check for normality? That's a big one they always skip. Large sample size will inflate the chi-square. Also, I didn't put on here small sample size. Increases error. Model complexity, so how many variables that messes up the model fit. Remedies. We talked about checking modification indices. That's it for tomorrow, actually. Oh, this one. Let's do this. Prevention. Let's do this. We're going to do this one really quick. let's say you didn't have a good fit, you didn't know what to do, and you're stuck, right? You're up against a wall. You have no clue how to fix it. You can go to Analysis Properties, Output, and instead of modification indices, we're going to do residual moments. I think that's the one. Residual moments. Right there. What this is going to do is it's going to, you know how I said when you do a model fit, it takes the observed covariance matrix and the proposed covariance matrix and creates a difference out of them? It's going to create a matrix for those difference values. So you can identify what's causing the problem. So close that, run this, and if you go to your output and go to your estimates, matrices is new. And you want your standardized residual covariances. And it produces this massive matrix, like really big oh, that's not too big. That's all right. But still, you don't want to have to be like manually searching through this. So I made a little tool that'll do it for you. If you right click and copy it, and then go to the Excel tools, and go to Fit Check, and paste it in there, and click the button. It'll tell you what the biggest problem is. It says social desirability 5 is the biggest problem, causing model fit issues. Well, we're not going to get rid of social desirability 5. So that's a bummer. But if you just look on the diagonal here, this is the sum of the residual problems. So you can go look to see which one is causing those problems. Let's ignore social desirability. Get rid of those. Okay, and now we can see which one's the biggest. 24, 24, 27s, 27. Looks like 28 down here. You saw a 29 somewhere? I see a 28. Anxiety 7. That's a 25 for me. Oh, thank you. Oh, 29. So anxiety 7 is the one causing the most model fit issues. It's the one inflating the chi-square the most. Essentially inflating the chi-square by 29.817. If we were to delete anxiety 7, if it's an option, we could decrease our chi-square and essentially improve our model fit. So that's what this does. Yeah.
But clearly, there's a motivation to have as many questions grouped as possible, as well as go to you've gone too frequently is can we get rid of it? Can we get rid of it?
Yeah.
So you have to ride that balance between asking the velocity of ammunition.
So for the remote folks, this is a really good point. There's a compromise and a balance between having a lot of redundancy built in so that you can delete items and not fatiguing survey takers. You want more items so that you have the flexibility to delete them later, but you want fewer items so that they don't get fatigued when taking your survey. What do? Pretest a lot and then reduce. Because I didn't pretest this a lot. This was my first year here at BYU, and this data was from a pre-PhD class, a doctoral seminar. We only did this as an exercise. And it turned out the data was so fun and good that we were able to use it for all sorts of things like this boot camp. We've never actually published anything with it. But we didn't have the best practices when we did it. I was brand new, I didn't know what I was doing. And I was working with doctoral students who are actually master's level students who didn't know what they were doing at all. And so we didn't pretest. Had we pretested more, I bet we could have deleted a lot less during this exercise. Okay, yeah. Let's go back to the slides, make sure we haven't missed anything. That's on prevention. That's what that was for. Pretest, pretest, pretest. Multi-group invariance, we talked about that. And we did method bias. Oh, this one. You asked for this specifically. Second order factors. We need to cover this real quick. Not real quick, we're good. We have plenty of time. Let's say we take a, are we good? Or do we want to take a brief break? Are we good? We're good. Okay, we're good. Okay. Let's say you have two variables that are highly similar. For example, decision quality, information acquisition. When I wrote this survey, they were the same construct, and I split them up afterwards. So let's say they're highly related, and we really think that they are the same thing, or at least dimensions of the same thing. What I'm going to do is I'm going to move these around to make things easier to work with. I'm going to move comp use out of here, move decision quality down here. There we go. Now, information acquisition and decision quality are together. If you want, you can recreate this right here. There we go. Okay. And what we're going to do is we're going to create a higher order construct. Say that decision quality and information acquisition are really two dimensions of the same thing, which we would call system success. Because it is a success, is a manifestation of success if we have good decisions and good information. So I'm going to zoom in here and make this construct. Okay, the way you do that, you get the ellipse, you make a new latent factor here, you delete all of the covariances that are attached to these lower order constructs. And then you draw a line from the higher order to the lower order, higher order to lower order, name it system success, or whatever, system success. Zoom out a bit. There we go. And resize it so it's not ugly. Make it pretty. Okay, so something like that. And then you need to covary everything with system success instead of with those lower order items, lower order factors. So one way you can do that is just highlight this one, system success, and all these other highest order factors. In this case, they're first order. The only ones you don't highlight are these lower order dimensions. And then go to plugins, draw covariances. The last thing you need to do is double click. Oh, I have resized on, whoops. Double click one of the lines, just pick one, and give it a path constraint. Because each latent factor, the highest level, or each latent factor needs a constraint somewhere. Sorry, I went really fast. This single-headed arrow, if you click on system success, and then release on the other variable, make sure it's on and on, not next to, on to on. Yeah. It should turn red and then release. I'll be there in just a sec. Okay, cool. So you can't, so others might be having this trouble too. You can't regress on a variable that's being covaried. And so you have to delete all the covariances first, and then you can do a regression. Yep. Yeah, no covariances with the lower order factors. No, between any. So notice I have no covariances whatsoever with those. And then what you do is you could do validity and model fit with it all at this level. How would you do method bias with it at this level? It still attaches to the observed variables. That's CLF. But then notice the social desirability connects to the highest order constructs only. Yeah, if we decided to create factor scores out of all this, we would use system success, not decision quality and information acquisition. And I'll show that tomorrow when we actually do it. Let me see if this works. I'm going to run it, see if it actually works. Oh, last thing, it says you don't have error terms on those two variables. Yeah, so this is the error term thing. It's the box head thing. Down, click and click. And then also go to plugins, name unobserved to rename those as error terms. And that was plugins name unobserved. And now it should run. Yay, it ran. And look, it's actually pretty good. Look at that, 78 and 87. Those are nice loadings. So anytime you do a higher order model, typically you need to do a model comparison. The way you do that is through a model fit comparison. You can do that through a chi-square change or a CFI change, or called CFI, or delta CFI, where you see the CFI for one model and the other model, and if they're not more than, I think it's 0.1 different, then they're equivalent. So you could use either model. Yeah, yeah. Is it better? Yeah. So you'd have to look at the chi-square difference test and the CFI. So let's just go look at the CFI right now. Yeah. It'll give you the deltas. Cool. I've never played with that. Cool.
I mean, I delete those.
Oh, okay.
I don't know what
I'll have to play with that more and I'll let you know. Did you have error terms on those first order? Did you have a path constraint on one of the paths? In the first order, yeah. So you have a path constraint on that one. You're welcome. But notice our model fit is still good. In fact, it's great at this level. It's CFI 0.953, peak flows of 998. Good. I could. What I do is I check. I probably wouldn't do this unless I couldn't get it to work at the first order level. If I was having discriminant validity issues, I'd combine them and say, hey, look, it works. But if I had already theorized about them separately, I wouldn't try to combine them now, unless they just wouldn't work separately. Oh yeah, if I was just exploring, I'd see which one worked better and go with that. The chat window. If we don't use the plugin for model fit, we can still use the output, right? Oh yeah, totally. The plugin keeps giving you an error. Sorry, yeah, and it doesn't work if you have the CLF present. It also doesn't work with higher order constructs. I don't know why. We need to fix that. What about removing unnecessary paths in that model? In a CFA, no. In a CFA, there are no unnecessary paths. Everything is specified precisely. In a causal model, there can be unnecessary paths, and we'll show that tomorrow. So just to confirm, the second order should be reflective in SPSS. In Amos, you mean? Notice the way I drew it. It is reflective. The lines go from the highest order construct to the first order constructs. So that's reflective. If I were to draw the lines the other way, that's formative. There's actually a way to do it in Amos, but it's not built for that, and so I wouldn't recommend that. What about, that's what I know, just to do it. Last one. Does CFI have to be greater than 0.95, or is it acceptable to have 0.895? As with all statistics, it's an arbitrary cutoff. So if you can argue for the reason why you're willing to accept a lower cutoff, then sure, you're good. Particularly with fairly complex models, a 0.9 is usually sufficient. Okay. All those covariances. I actually use the plugin for that. If you highlight with the pointer finger each of them, then you go to plugin straw covariances, and then it works. Yeah. Let's see if we missed anything else. Computing factor scores. We're going to do that today. Why not today? Let's just do it today. And I think that's it. Yeah. Cool. Let's do that today. So the last thing is to, there's an option. You don't have to do this, but you have the option to calculate factor scores for all of the latent factors. We did this for an EFA where we took each factor and collapsed it into a single weighted average. You can do that here as well, and it's actually more accurate than the EFA. The way you do that is go to Analyze, Data Imputation. Analyze, Data Imputation. And a window will pop up. Let me zoom out. Zoom back in. Here we go. You're just going to accept the defaults using regression imputation. There are actually reasons why you'd want to use the others, but not for our data. And I'm not going to explain it. Except it's like in non-normal situations or when you have binary factors, which I don't recommend. Okay, so you can rename it if you want, but the default name is whatever the name of the data set was before, _C. This is called bootcamp trimmed _C. Just hit impute, and it will hopefully pop up a little window that says it was created. Hit OK, and then you run into an Amos error where it enters an infinite loop of busyness. Yeah. So the only way to fix that is to close Amos. Yeah. If you want to save, yeah, you should, I'm going to actually cancel. See if I can. Oh, you could just. Yeah, if I canceled it, fixed it. But I'm going to save this as second order. Save as CFA second order. Every time. Okay, if you go look at your datasets folder, or the one I have shared with you, let's see, SEM series, dataset. Here it is, bootcamp trimmed _C. If we go look at that now, yes. This data set just popped up. And if we go look at the variable view at the very bottom, you'll see we have a new set of variables. These ones right here. Actually, not early adopter. It's starting here with system success. We have system success, social desirability, all these factors we had. 1, 2, 3, 4, 5, 6, 7, 8. Zoom out, sorry. Which is what we had here, right? 1, 2, 3, 4, 5, 6, 7, 8. It actually created factor scores for the lower order factors and the highest order factors. So we have a system success factor score. We can then go use those in regressions or in path models or in ANOVAs or whatever we want. They're just weighted scores. So if I go look at the values, let me show you. Go click on, let's do system satisfaction. Notice it's just a weighted score. So you'll see numbers roughly between 1 and 5, because that's what our original scale was, but maybe a little bit more, a little bit less, because there's weighting going on. Cool. And that's that. So we now have individual scores for each latent factor, which we may or may not use. We'll see. Okay. Any questions regarding the stuff for today? I think I'm not going to fire hose you with any more. We're not going to move on to tomorrow's topics. I'll just work one-on-one with you, or if somebody wants me to do a CFA with their data, I'm happy to do that up on the big board. Except DM students, I may not do yours. So does anyone have data they want me to do a CFA on, or should we just work one-on-one on stuff? Okay, one-on-one. Unless somebody on chat says, oh, is this imputed factor score based on CFA highly different from EFA? The answer is not highly different, no, but slightly different. Why is it different? Because we have constrained it. We've said these items belong to this factor, whereas in the EFA it was completely unconstrained. And so the weights are going to be slightly different. Which ones are more accurate? The ones in the CFA are more accurate. Yeah. Okay, we'll just start working one-on-one. Remote folks, you're welcome to take off unless you want me to work with you one-on-one on something. I'm going to stop recording though. So if I work one-on-one with you, you don't have to worry about it being recorded yeah, and shown to the world. So I'm going to stop sharing my screen. I'm going to stop recording.